Hello students, my name is Dr. Gajendra Purohit and you are watching our YouTube channel where I upload videos for engineering mathematics B.Sc. If you are preparing for any competitive exams where higher mathematics is asked, our YouTube channel is very helpful for you. So today I am going to explain how to find the particular integral in a difference equation. Normally our answer is CF plus PI, right? So I explained how to find CF in the previous video. If you haven't seen it, go to IIT-JAM and watch. Today I will tell you how to solve a particular integral in difference equation in numerical analysis. So let's get started. So let's discuss this. Whenever we have any kind of difference equation, it's linear difference equation, and here we have function fn. So first we will convert this into its auxiliary equation, and phi e is its auxiliary equation. We will take this to the denominator. Normally we have differential equation. We know that we can write it like this. For example, let's say we have function px. So what we do is px upon, we have fd, and then here we will find its particular integral. The concept is same here. Whatever auxiliary equation we have, we will take it down and then we will solve according to the function. Now I will try to explain function one by one. First of all, we'll talk about the a power n type of function if the function we have is a power n type. So what will we do in this? We have an auxiliary equation phi e, and here we have yn, and suppose this is a power n. So students, yn is equal to a power n phi e. Students, wherever there is an e, we will put a. What will we put here? We'll put a, but a that we have should not be equal to 0. Now you might think, what if a becomes 0? In that case, what will we do? So I will explain a trick. Though the formula that we have is if denominator becomes 0, then we have e minus a power m phi e, and if upon putting a denominator is becoming 0, and this is power m then. When we differentiate it m times, we get m factorial, and when we do its derivative n times, n comes in front. Then n minus 1, we do its derivative till m minus 1 of this a, right? You can easily remember this formula by this concept, this trick. What will we do here if we get 0 once? Then this n will come forward and this will be a power n minus 1. So what will we have here? Phi dash e, okay. So we will put phi dash e here. Now what we will do here again, we will use yn. So n a power n minus 1, it will be phi dash a. It's the same thing again, value of phi dash a should not be 0. We will keep doing this process until we get something which is not 0 here. I am going to take an example in front of you. Like see here, we have this example, whereby n plus 2 minus 4y n plus 1 minus 4y n is equal to 2 power n. Okay, what are we going to do with this? We will write e square yn minus 4 minus 4 yn is equal to 2 power n, right? So here it will come e square minus 4e minus 4 into yn is equal to 2 power n. Is it clear? So we will take this to the denominator. So yn is equal to 2 power n upon e square minus 4e minus 4. I am telling you its particular integral. You might wonder what will be its CF, so I will tell you about it. So to find its CF, it would be e square minus 4e minus 4 is equal to 0. I explained this in the previous video. If you haven't seen it, you can go and watch it. It will be whole square of e minus 2 is equals to 0. So here the value of e will be 2.2, right? And here CF will be C1 plus C2n 2 power n. Is it correct? Okay, we have its CF end. Then we will find its particular integral. So wherever there is e, we will put 2 there. And as we put 2, then it will become 0. Since it is 0, then what will we do? Here n will come forward 2 to the power of n minus 1. If we do its derivative, it will be 2e minus 4. Again put 2 here, so 4 minus 4 is again 0. We will take its derivative again, right? So here we will get n into n minus 1, 2 to the power of n minus 2. So here in denominator we get 2. So this what we have here, this will be its particular integral. Then the final answer will be RPI. So the final answer we have is yn is equals to CF plus pi, right? So what will be our CF? It's C1 plus C2n, 2 power n plus n into n minus 1 upon 2 and 2 to the power of n minus 2. So it will be our answer. Right, students? So this here, what is this? It is particular integral. We do it like this. So let's move to the next concept. If we have cos or sine here, just like we have a differential equation, it's same concept. So here we have cos kn and sine kn, and we have to find its particular integral. If you remember, so what we do in this differential equation, that f dy is equal to cos ax. Okay, we will take this fd down. This is about differential equations, so that you can learn from it very easily. This will be cos ax, and in denominator minus a square, whatever the angle is, it is squared and subtracted. Same concept applies here. Nothing new, so don't worry about that, right? So we have this differential equation, right? Look here, we have yn plus 2 minus 7 yn plus 1 plus 12 yn is equal to cos n. Okay, so here we will get this e square yn minus 7e yn plus 12 yn is equal to cos n. Is it clear to you? Okay, first we will do e square minus 7e plus 12, and you can take out this yn, and this will be cos n. First we will calculate CF, and to find CF, what will we do? E square minus 7e plus 12 is equal to 0. So look here, it will be e minus 4 into e minus 3. These are its factors, okay? If we solve them, then the value of e will be 4 and 3. So the CF will be C1 3 to the power n plus C2 4 to the power n. Here this will be the value of CF. Now we talk about the particular integral. So this will be yn is equal to, this will be cos n upon e square minus 7e plus 12. The coefficient of n is 1, it's cos n, so coefficient is 1. Wherever there is e square, it will be minus 1 square. So here its value will be cos n. So this is minus 1 square minus 7e plus 12. If you write this, it will be, this will be cos n upon, here we will have minus 7 plus 11. I will do one thing, take this minus out as it is common. This will be 7e minus 11, right? Now what happens is, when we talk about differential equations, we rationalize it. That means we multiply and divide 7e plus 11 both up and down. Students, we multiply up and down by this 7e plus 11 so that we get e square here. So here we will get yn is equal to 7e plus 11, and here it will be cos n, and we will divide it by, here at the denominator, we will have, please look carefully, minus 49 e square minus 121, okay? Here at place of e square, if we put minus 1 square, it will be minus 49. So minus 49 minus 121 is minus 170. What will come here? 170, right? So this will be 170 in denominator. So this e, we need to convert this here, and listen students, we know that del is equal to e minus I, right? So the value of e here, it will be del plus I. So wherever there is e, we will place del plus I there, so that things are easily solved. So it will be del plus I, right, and plus 11. So here we will have cos n, right students? Now here we will get yn is equal to 7d plus 7 and 11. So this will be 18, right? It will be multiplied by cos n. Upon here we already have 170. Here derivative of cos n, can you see d here? D means del and del means derivative, right? The derivative of cos n, here it will be sin n, which will be negative, and then here we will have plus 18 cos n divided by 170. Right students? So we got its particular integral now. Then the final answer we will get is CF plus PI. So we can very easily do this. So next we'll see if the function we have is of n power p type. Then in that case, what will we do? Whenever we have n to the power p type of function, then we need to first convert it into factorial notation. Now question will arise in your mind, what is factorial notation? If you have seen my videos, I had uploaded a video before this. Means a few days before this video, where I explained about operations. I explained the different operators that we have. I explained all of them. I also explained factorial notation. But I will tell you a little bit about it. If we have any factorial notation, let's say we have n cube. If you want to write this in factorial notation, we write it as an to the power of 3 plus here be n to the power of 2 plus we have this cn to the power of 1, and then here we will have d. Okay. Convert this into factorial notation. See how will we do it. So here we have n cube. It means n into n minus 1 into n minus 2 plus b. Okay, so this comes as n into n minus 1 plus cn plus d. So we do it like this here, right? Now what we do here is compare these values. So you are seeing the coefficient of n cube here is 1, and here the coefficient of n cube is a. Clear? So the value of a here is 1. Okay, if you look here, the coefficient of n square. So here if we talk about the coefficient of n square, what it will be, if you see here, I will multiply this so that you can understand it better. Here we get n square and minus 3n and plus 2. Okay. So the n square that we will get, it will be minus 3n square. So this will come as minus 3a, and here we will have b, right? Here its value will be 0. Why is it 0? Because there is no n square here, right? Now we will talk about the coefficient of n. It will be 2. Here a is getting multiplied. So this will be 2a. In that case, what will we get here? It will be 2a minus b plus c is equals to 0, right? Now discussing about constants. So constant is not here. The constant that we are getting here, I think only d is there, right? So this d is going to be 0 anyway. So I think this is anyway 0. Clear? Now what we do, a's value is 1, and if you put this a's value in it, then b's value will be 3. Now we got the value of a and b. Now put them here. This will be 2. This is minus 3 plus c. So from here, the value of c will be 1. Okay, put it here. So here the factorial notation of n cube will be value of a is 1. So here its value will be n to the power 3 plus b's value is 3. And here we will get 3n to the power 2. And c's value is n here. Okay. When you simplify this, it will ultimately be equal to n cube. So this is how we convert it to factorial notation. This is needed later. I have told you this earlier in previous videos, right? Now we are talking about that ultimately whenever we have n power p type, you must have seen whenever we solve a differential equation. If we have anything of type x power n, then what we do here, this x power n upon fd, then we take this up and solve with the binomial expansion, right? Similarly, we will be using binomial expansion here, but first you have to convert it shift operator into del. Then you can use this concept here. Let me show you how. I will try to explain this to you. Please look here and try to understand. Okay. We have this difference equation given here. The difference equation that we have is yn plus 2 plus yn plus 1, right? Plus yn is equal to. Here we are getting this as n square. So first of all, what we will do is convert this n square into factorial notation. So how do we do this? Tell me. This n square is equal to an2 plus bn1 plus c. What will we write this as? We will write it as n square is equal to an into n minus 1 plus bn plus c. First coefficient of n square, value of a is 1. Then we will look at, please focus here, then we look at the coefficient of n. Here coefficient of n is minus a and here it's b is equal to 0. We put value of a here, then value of b will be 1 and c is 0. So value of a and b is 1. Factorial notation of n square will be n to the power 2 plus n to the power 1. Now you will ask, how does it come? So when you open this and write this, n into n minus 1 plus n, then you will cancel this. It will be n square. Is it clear? In this way we convert this into notation so that we can easily do its derivative. Let's get to the point. Here we will write this as e square yn plus eyn plus yn. Now if we convert this into notation, this will become n2 plus n1. Is it clear? This is the value that we will have. E square plus e plus 1. And this will be yn to the power of 2 plus 1, right? Now what should we do? First of all, we'll find the CF ones. Anyway, we need it because whenever you are asked to solve it, you need to find the CF and set it to 0, right? So the value of e will be b minus 1 plus minus b square, which is 1 minus 4 upon 2. Is it clear? From here we get the value as minus 1 plus minus root 3 iota divided by 2. So here we are calculating the value of r. Am I right? Here alpha that is given, I had told you in the previous video about CF. Write the imaginary and real parts separately. So the value of r here will be alpha square plus beta square. So this will be 1 by 4 plus 3 by 4. So its value will be 1. Then we will calculate theta. It's tan inverse y by x. Value of y is root 3 by 2 minus 1 by 2. So we will get tan inverse minus root 3, right? Minus root 3. So the angle we get here will be pi minus pi by 6, right? What will we get? Pi minus pi by 6. Okay. We know that value of tan root 3 is pi by 3. So the value we will get is pi minus pi by 3 because it's negative. If we solve it, we get 3 and 2. From here we get its value as 2 pi by 3. So the answer that we get is CF. This is CF. So here we get this as r power n and C1 cos and theta plus C2 sin and theta. So the value of r is 1. So it's 1 power n. This is CF here, right? And this will be C1 cos n2 pi by 3 and C2 sin 2n pi by 3, right? So this will be CF, okay? Let's talk about particular integral. In particular integral, what do we do? First, we convert this e to del. So bring it down. This will come as yn, and here we will get n to the power 2, right? We will get this now divided by. Take this down. So we know that wherever the value we have, that is, del is equal to e minus 1. So the value of e is del plus I, right? So we will apply that here. Okay, so wherever there is e, put whole square of del plus I, plus here, this will be del plus I, and plus this is 1. We can also put I here, right? In factorial notation, we have n to the power 1, right? We call it factorial 2 or factorial 1. So it will be factorial 2 and factorial 1 divided by. Okay, if we simplify this here, we'll get del square and then it's 2 del and del. So we have 3 del here and then this is 1, 1, 1. So we have 3 here. So like we do in differential equations, we take 3 as common, take it up and then we will inverse it. Yn is equal to, here we will get 1 by 3 and then this will come as 1 plus del square plus 3 del divided by 3 going up, it will be inversed and this will be factorial notation of this, right? So here we will get its value. Now we will expand this and I am writing its expansion there. So you can understand it very easily, right students? I think you have understood this point, right? So I will do this. Here we have yn is equal to, open this will get 1 by 3, apply binomial expansion. So here it will be 1 minus del square plus 3 del by, here we have 3, are you getting it? Plus whole square of del square plus 3 del by 3, right students? Therefore, as you can see, what will we get here? It will be n square plus n1. This is its value. So here we will have the value of yn as 1 by 3, 1 minus. And here it will be 3 del by 3, right? It's 3 del by 3 minus del square upon 3. And students, here we will have plus 9 del square upon 9. And here this term will come, right? Leave the rest because we only need power till 2. Rest of the terms are not useful for us, right students? So when we will simplify this, we get it as yn is equals to 1 by 3 and 1 minus. This will become del here and this will be del square by 3 minus del square by 3 and this is del square. From here we will get its value which is 2 del square by 3. Okay, this will be 2 del square by 3 and here we will get this as n to the power 2 plus n to the power 1. So this is its value, right? So when you take this inside, then yn is equal to 1 by 3. So from here we have 2 factorial and this will be 1 factorial minus, now we will do derivative of this and its derivative will be 2n, right? So its derivative will be 2n plus 1, right? Because if we do its derivative, this will be 2n and this will be 1 and if we do it twice then it will be 2. So this we will get 4 by 3. Now let's simplify this. Convert factorial notation again. From here we will get its value as n into n minus 1 plus n. So here we will get its value as n into n minus 1. When we will do plus n, n will be cancelled out with n. So it will be n square. So I will write it as n square only as we don't have much space. So this will be 2n and from here minus 1 plus 4 by 3. So therefore it will be plus 1 by 3, right? Okay. And this we have is its particular integral this way. We can do it here. Okay. Let's move on to the next function. If we have a product function, means a power n into fn, then what do we do in that case? So if we discuss differential equations, there we have f dy. If you have studied it earlier, we get it like e to the power x vx. So what we do here, y is equal to e to the power x into vx divided by this fd comes here. Then we will bring out e to the power x. So here where there is d, put d plus 1 there. It means if power is 1, then we will use d plus 1. It will be same here. We will take out this a to the power and wherever there is e, it will be ae. Here it's plus, but here it will multiply. Then we will calculate its pi. Like we calculated here, for example, we have been given this question here. It's given that yn plus 1 minus 3yn is equals to n square and 2 to the power n. Let's say you need to find particular integral here. So first what we will do, we will write it here. So it will be e, right? And here its value that we will have is yn minus 3yn is equal to n square 2 to the power n. This will be e minus 3yn is equals to n square 2 to the power n. First we will find CF. We know that e minus 3 is equals to 0 implies we will get the value of e as 3 and the value of CF that we will get. It will be C1 3 to the power n, right students? If we talk about particular integral, it will go down. We know that yn is equal to, this will go below. Then we will get n square 2 to the power n by e minus 3. Now we will take this 2 to the power n out. So this 2 to the power n will come out. Wherever there is e, it will be 2e. Remember, it gets multiplied, right? Okay, this a, it will be multiplied by e, and this 2, it will be multiplied by 2e. So it will become 2e, right? We will use concept of factorial notation. So here it will be yn. I told you in the previous question that in factorial notation its value is, we have this value divided by, here we will write it as del plus I, right? Minus 3 instead of e. We can write this yn is equal to, this will be 2 to the power n. This will be 2 factorial and 1 factorial, it will be divided by 2 del, right? And this 2 will be subtracted from minus 3, so we will get here minus 1. Right, students? Now what should we do? We will take out minus common. This will be minus 2 to the power n, and then it will go up. So 1 minus 2 del. This will be factorial notation 2 and 1. This will be the value that we will get, and this will go up and will be inversed. This will be yn is equal to minus 2 power n. We will open this. 1 plus 2 del plus 4 del square. These terms will keep coming. As the highest power is 2, we will consider till that power. Rest is not relevant. Now students, be attentive. Multiply this inside. When you do this, yn will be equal to minus 2 power n. When you take it inside, then this will be n2 plus n1. Okay? We will take its derivative. From here we will get its value. 2 into 2, this will be 2n, and here we will have its value as 1. We will do its derivative twice, so its value will be 2. So 4 into 2 will be 8. We will do its derivative normally, like we do. Simplify this a bit. So students, we know that this value that came here, its value is equal to what? The value of n square. I told you in factorial notation, its value is n2 factorial, n1 factorial. So we can replace n square with this. This we will get as n square plus 4n. And what will we get here? 10. Okay. So here, this will be the particular integral of this. So this way, we can solve this question very easily. Next, I will try to explain some more questions like this. Okay, first we'll do this. It will be e square yn plus 7e. Here it will be yn plus 10yn is equals to 12. And this will be 5 to the power n, right? What will we do here? This will be e square plus 7e plus 10 into yn is equal to, this will be 12. Here we will have its value as 5 to the power n. So what will we do here? E square plus 7e plus 10 is equal to 0, right? So if we simplify this, the value of e will be 5 and 2. Okay, students. So the CF will be yn is equal to C1 5 to the power n plus C2 2 to the power n. Now we'll find the particular integral. So yn is equal to 12 5 to the power n upon. Here we will have e square plus 7e plus 10. Okay. Wherever there is e, replace it with 5. This is like the concept of e power x. 12 and this will be 5 to the power n. If we will put this, it will be 25 plus 5 into 7, it's 35. So here we will get 60 and 10, 70. Here this will be yn is equal to 12 into 5 to the power of n upon 70. So the final answer that we will have is CF plus PI. Here this will be C1 5 to the power n plus C2 2 to the power n plus here it will be 12 into 5 to the power n upon 70. Okay. So here we have the answer of it. And this way we can solve this question very easily. So next question is yn plus 2 plus yn is equal to sin n pi by 2. Okay, what will we do again? We are going to write this. So this will be e square yn plus yn is equals to sin n pi by 2, right? So here we will get this as e square plus this yn is equal to sin n pi by 2, right? What will we do here? We will write e square plus 1 is equal to 0. So we will get e is equal to plus minus iota. If we look at its roots, then the real part is this and the imaginary part is 1. We know the value of r will be alpha square plus beta square. So the value of this will be 1 and we will get theta as tan inverse y by x. So beta by alpha means 1 by 0. So this will be pi by 2. So the right way to write the CF is this. Look carefully, students. R to the power n, C1 cos n theta plus C2 sin n theta. Clear? This will be yn equals to 1 to the power n. This will be 1 power n. And this will be C1 cos, here value of theta is pi by 2. So n pi by 2 plus C2 sin n pi by 2. So here this will be its CF. Now we'll talk about its particular integral. So what will we get here? Yn is equal to sin n pi by 2 divided by e square plus 1. Wherever there is e square, then its coefficient pi by 2, we will square it and then subtract it. I have already told you, right? So yn is equal to sin n pi by 2. So we will get this as minus pi square by 4 plus 1. Okay. When you simplify this, we will get the final answer as CF plus PI. So yn is equal to, we will get its value from here 1 to the power n. Let's write it. And this will be C1 cos n pi by 2 plus C2 sin n pi by 2. And what will be the particular integral of this? 4 will go up, right? So 4 sin n pi by 2 divided by, here it will be 4 minus pi square, right? So here we will have its particular integral and its CF, right? So this is how we solved it here, okay? So this question is for the comment box. How much time did it take you to solve it? Please comment and tell. If you want to watch videos of numerical analysis, entire playlist is available here. If you are preparing for any competitive exam and want to practice questions, whether it is IIT-JAM or CSIR net, you can do it. And you can subscribe to the channel here. Thank you very much. Bye-bye.